Right, the fourth and final type of plate boundary is what we call a destructive plate boundary. Again, two plates are coming towards each other. So this is a convergent plate boundary. But on this occasion, we're going to have two different types of plates, an oceanic and a continental. This means the two plates are of different density. So what you have in this situation is the more dense compact ocean plate will push underneath the less dense continental plate. And this will cause the continental plate to rise up and the oceanic plate to push down. So I will show you as I go through this process what's happening, but there will be a little bit of rubbing out as I do it, but what you're interested in is the final version. So let me start by showing what's happening here. So here we go, we have the continental plate moving towards the oceanic plate. So they're coming together. But when they come together, this one is more dense. So the oceanic plate will force its way underneath the continental plate. Not only does it force itself underneath, as it drags itself down, it causes this plate to drag down with it a little bit as well. Now this plate, the oceanic plate, is pushing deeper and deeper inside to the mantle. The mantle is between 700 to 3000 degrees centigrade. So as this plate pushes further down, it begins to melt. Right? So this is a continental plate, so we actually do have mountains on here to start with. Right? This is an oceanic plate, which is actually underneath the ocean. So this is compact under the ocean. This is your larger but less dense oceanic plate. This plate is being pushed under, and the term for that is called subducted. As it melts, it takes with it water from the ocean. So this makes this a more volatile and unstable kind of magma, not the same as the rest of the magma. It then begins to rise. So what happens is, and I'm going to use blue again, this magma begins to rise up. It will find the weakest points to come through, okay? And it will make its way to the surface. And it will create volcanoes and again mountains on the surface. So this is a slightly more complicated process. Not only that, as the plate moves underneath here, friction begins to build up. And when the plates move past each other, this can create an earthquake. And if this earthquake just happens to be underneath the sea, well then this can create a tsunami, which would then travel towards the land. So I'm going to do that diagram a little bit clearer and put the labels on for you now. So as you can see from the labels here, there's quite a lot more going on at a destructive plate boundary. First of all, the oceanic plate, which is more dense, is subducted. That means pushed underneath the number 2, the less dense continental plate, which gets dragged down with it. Now in my previous explanation I said it gets pushed up. Technically it does, because this is building up here as it's being pushed down here, but on the edges it's being dragged down. And as it gets dragged down, that makes the ocean deeper. As the continental plate eventually pushes inside the mantle, again the plate might stick and it might move with a sudden jolt, creating an earthquake. It begins to melt. And as it begins to melt, because it's mixed with seawater, it's a little bit more volatile, a little bit different to the rest of the magma underneath. So it's under pressure and it starts to rise. Eventually it finds the weakest places to come up, and eventually it reaches the surface and it can create volcanoes or mountains. I mentioned before that as the plates collide, they take each other down with them. So what we end up with are these features called ocean trenches. They're the deepest parts in the world's oceans, and they're all formed along destructive plate boundaries. So what we have on this boundary is we have ocean trenches, we have earthquakes, possible tsunamis, mountains, and very explosive volcanoes.